Okay, so now that we've relaid the foundation for how to solve basic mathematical equations, let's put aside our nice little pictures of scales and all that and look at how do we use symbolism, algebraic symbolism, to solve equations of different types. So we're going to do 2 or 3 here, and then we will pick that up in class. So let's take a look over here. We have the equation 2x plus 5x minus 4 equals 10. And I want us to think about the equal sign as being the center of balance here. So everything on the left is equal in weight, or however you want to think about it, to what's going on the right. So this is kind of like saying we have 2 suitcases plus 5 suitcases minus 4 pounds equals 10 pounds. And you can think about it in whatever way you want, but using some of the examples that we just talked about in the last topic, that's how we can visualize this. The question, of course, is, what does x equal? We want to solve for x. What's its value? What I would always recommend doing first is, if you're a person who likes lists, I'll make you a nice little list over here. Step 1 is see if there's anything you can simplify. Now what I mean by that is you have to keep each side of the balance of the scale, you got to keep it by itself. So you can't just say, oh look, I can take 4 and 10 and just put them together. No, they're on different sides of the scale, so we're not going to mess with that. However, over here on the left, this is all one side of the scale, so anything that can be simplified, I really should simplify. That means putting like terms together, and maybe I should actually write that. Simplify means let's put like terms together, or combine like terms. And as you may recall from the previous lesson, 2x and 5x are like terms because they both have an x in them. 2 x's plus 5 more x's is 7 x's. Again, that's the same as saying like 2 suitcases plus 5 suitcases is 7 suitcases. Why not write it simply if we can? Now, minus 4, that's a different thing. If we're talking weights, that's our weight. We're not going to combine that with the suitcases. On the right side, is there anything we can simplify? No, it's just 10. So we got to leave it as 10. So step 1 is done. We have simplified, we've combined the like terms that we can combine, and now we move to the second step. And that is get x by itself, or isolate the variable. I'm going to say isolate x. Now the variable could be x, it could be a, it could be c, it could be z, it could be any letter that we, or symbol that we choose, but I'll say isolate x just to be simple. Okay, what do we need to move away first? What is the first item that I want to move away from x? I want to think about what's furthest away. That would be minus 4, kind of like the weights. So do the opposite. If I want to get rid of minus 4, I need to add 4. And if I'm going to do it to the left, I'm going to do it to the right. That's the only way to keep the scale balanced. If I add 4 to the left side, it cancels out with the minus 4. They just kind of can't become 0. And on the right, I have 10 plus 4, that's 14. What does that leave on the left side? I just have 7x. On the right side, I have 14. So now I say, have I solved it? Have I finished step 2? No. How do I know I'm not done? Because x is not by itself. I still have this 7 hanging around over here. 7 times x. How do I get rid of 7 if it's multiplying x? Well, how do we undo multiplication? We divide. Get rid of a multiply by 7 by dividing by 7. And whatever I do to the left, I do to the right. 7 divided by 7, just that's 1x, right? It's like having 1 suitcase left over. We just have 1x. And what is 1x equal to? 14 divided by 7 is 2. So in this case, we have found that x equals 2. Have I completed step 2? Yes, I isolated x. And then the last step is always just to state the solution, which I've already done. I have stated here that x is equal to 2. And I recommend whenever you're doing work, whether it be homework, classwork, tests especially, circle or box your answer. It helps me as the teacher to be able to see what it is that you are stating as the step 3. What are you stating as the solution? So we've circled that and we did it. That is our example. Okay, just reviewing before I erase it, we started with an equation, 2x plus 5x minus 4 equals 10. The first thing we did was simplify. Now we stayed on we kept the sides of the scale separate. We simplified the left side and we simplified the right side. You don't want them invading. You don't want to mix the left side and the right side. So all we did is we looked at the like terms on the left, and then we saw that, well, there's only one term on the right, so we can't combine like terms. Second step was to isolate x. That was to see what we need to move away to get x by itself. First thing we had to move was the 4. Get rid of the 4, the minus 4, by adding 4. And then the next step was divide by 7 to get rid of the multiplying by 7. That left us with x by itself, and it also gave us the ability to state the solution. X equals 2 is our solution. Okay, we're going to start a second example. And the example that I'm going to give us is 3x minus 5 equals 2x plus 4. And I'm going to rewrite actually our steps. It was simplify, if you can, on each side, the left side and the right side separately. Then we isolate x, or isolate the variable, whatever the variable is, and then we state our solution. So looking at our example, 3x minus 5, 2x plus 4, we need to keep thinking of this as if it was a little scale here, right? Do you like my little scale? There we go. It's my lame attempt. Okay, we're going to keep the sides of the scale to themselves. Don't go mixing the 3x on the left with the 2x on the right. That'll just give us big problems. We won't get the correct answer. So we always want to think about the equal sign as being a very firm dividing line, left and right. And we ask ourselves the first question, can we simplify? Now on the left side I have a 3x and a minus 5. So this is what we would call an x term, and this is just a number term. I'll use my little pound sign again to represent number. Can we combine these? No, we can't. They're not the same. They're not like terms, so no, we can't combine them. On the right side, we have exactly the same situation. We have an x term, and we have a numeric, just a regular number term. Can I combine them? No, absolutely not. They're not the same type of terms, so we don't try to simplify. So, step 1 is done. We didn't do anything, but we identified there's nothing that we can simplify. So we move to the next step. We need to isolate x. Now this creates kind of a question. Wait a minute, there are two x's. Did you notice there's an x on the left and there's an x on the right? What do we do about that? Well, this is what we call getting all the variables on one side. So this is kind of like a little addendum. So we have a problem. There are two x's. So what do we need to do? We need to get the x's together. Get the x's together. It doesn't matter which side, but I like to move them to the left. It's just a habit. So I'm going to say I have 3 x's on the left. I have 2 x's on the right. So this is like having, let's say I have 1, 2, 3 suitcases, like my suitcases. That's pretty crazy over there. And I have 2 suitcases. If that's what X means, I have 2 mystery suitcases of the same weight on the right. So how could I make this just put all the suitcases on one side? Well, I could actually take two two suitcases away from both sides, right? That would keep the scale the same. Take one away from the left and take one away from the right. Take one away from the left, take one away from the right. Will that keep our scale balanced? Absolutely. Now, what does that mean symbolically? Well, it means that I'm taking these two suitcases and I'm saying minus 2x, minus 2x, because whatever I do to the right, I have to do to the left. If I say 2x minus 2x, well, that's great. Now they go away. 2x minus 2x means the suitcases are gone, or the x's, the variables, are gone. On the left, 3x minus 2x is going to give me just one x left over. It's like that one suitcase. Are we still balanced? Yes, as long as we keep our extra numbers here. So now, how many x's do we have in our equation? Just one over here. Now this makes it a lot easier to solve. We're back to a problem just like we solved before. How do I get x by itself? Well, the only thing between us and is giving the solution is this minus 5. So to get rid of a minus 5, we add 5. Whatever we do to the left, we do to the right. That leaves us with just an x. Actually, let me not make that crossing out look like an x, just so I don't confuse people. So those undo each other. We just have x on the left, and 4 plus 5 is 9 on the right. So did we isolate x? Yes. Can we state our solution now? Yes. X must equal 9. We're going to talk about what that actually means in just a moment. Take a second to look at that. I'm going to actually, I'm going to clear this off and rewrite it without all the scribbles so that we can look at it nice and clearly. I just want a new. No, we don't need to save. Okay, so we had 3x minus 5 equals 2x plus 4. And we said that we should subtract 2x from both sides, which gave me just x minus 5 equals 4. And then we added 5 to both sides, which gave me just x equals 9. What I want us to talk about now is how do I know that I got the correct answer? If you're the type of student who likes to go back and check your answer, how do I know that x equals 9 is correct? Well, here's what it means. It means that if I go back to my original equation, which I'm going to write again here, 3x minus 5 equals 2x plus 4, means if I replace this mystery variable with the number 9, which is what I said my answer is, right? If I replace it with the mystery number 9, I should get a balanced equation. I should get like a balanced scale. Let's see what we mean by that. So in other words, I'm substituting 9 for x. So it'll be 3 times 9 minus 5 equals 2 times 9 plus 4. Now you can just write 2 times 9, or you can write it with parentheses. I like to use parentheses. It seems clearer to me, but it's fine if you just want to say 3 times 9. Now we go through our order of operations. We look at the parentheses first. Well, there's nothing we can simplify within the parentheses, so we're okay. I look for exponents. Are there exponents? No. So we don't have to worry about that. Is there multiplication? Yeah, or division? Yes, there is. So we're going to do that from left to right. 3 times 9 is 27. Then we don't touch this. We leave it alone. And then on the right side, we have 2 times 9, which is 18. Then we don't touch the 4. We leave it there. Okay, so we looked at the parentheses, we looked for powers, we looked for multiplication and division, and then lastly we look to see if we can do any addition or subtraction, and we do it from left to right. So we do 27 minus 5 gives me 22, and then I look on the right, 18 plus 4 is also 22. So are we balanced? Yes, that's a good sign. So did we get the correct answer? Yes, we did. Okay, let's just summarize before we finish. That was a big noise, but does not have anything to do with our homework. So let's think about what we've learned. When we solve an equation, essentially what we're doing is we have a symbolic scale. The stuff on this would be your left side. The stuff on the left side is the same weight, or has the same amount as the stuff on the right side. It should be balanced. Now, it might look like different things, like potatoes and kiwis. Like, we don't have to have the same numbers on either side for it to be balanced. But an equation is a balance of numbers and symbols. And our goal, typically and especially in this section, is going to be to figure out what the mystery variable weighs, what the mystery variable is worth. So in the first one, I think it was worth 2, x equaled 2. Then we had an example where x equaled 3. And the last one we had, actually, what was it? We had x equaled 2 again and x equaled 9. So we can get all different variables, like answers, solutions to our variables, but we know we got it correct if we go back to our original equation, plug it in, and it's balanced. So balance is key, just like life, right? Keep everything in balance. So that's it for your lesson for tonight, and we'll talk more about this in class.